Hey, this is Don from Padlock Technologies again with another video. This video is going to be a lab video and I will be demoing MVPN on this one. So I'm going to do profile 13, which is GRE base with BGP signaling for CPIM, which is customer PIM. Now, you've probably seen this environment. Well, I don't think you did this. I actually changed up the environment for my last MPLS videos. This is going to be LDP based, so we're not doing segment routing here. These two routers here that are in purple are going to be route reflectors, and then everybody else is going to be PEs. The RP is going to be router 16 down here. The multicast server, or the server per se that's going to be looking for the multicast traffic, is going to be this server, and then this router, and then everybody else are going to be clients, right? So what basically is going to happen is I am going to simulate MPLS going over the service provider network to the clients. So again, this is profile 13. This is PPIM. You're going to have CPIM. BGP is going to be doing the CPIM or C customer PIM signaling. And then once I go on to the multicast server and I ping the multicast address, you're going to see everybody reply. Now, some things to keep in mind here. I am running SSM default, right? So source specific multicast in the service provider network, and I'm doing regular multicast in the client network. There's only one client here, one VRF, and everything's going to be in there. I also have some iOS XR devices in here, so you get to see the difference between iOS and iOS XR. Technically, this is going to be iOS XE and iOS XR. There is some little things that you need to be aware of because the commands are totally different. So I'm not going to bore you with showing you the lib and showing you OSPF and all that good stuff. I have plenty of videos about that. If you want to learn about signaling and the many ways or 4 ways you can do MPLS labeling, I got videos galore about that. I have a whole playlist that you can look at. Now, from an OSPF standpoint, it's basic OSPF. No real trickery there. I'm doing autoconfig for LDP. I'm doing LDP synchronization. That's really all I'm doing there. From a BGP standpoint, like I said, router 18 and 17 are route reflectors. So let's take a look at the route reflector configuration here. And that is going to be, C show run router BGP. So here's all the configurations here. I'm not doing VPLS here as well. It's just strictly VPN v4 and VPN. So if we look up here at the top, we have our policy that I usually do. I do a peer policy for everything, and then do a peer session. So if you don't even know anything about templates, you can templatize configurations and then inherit those configurations per your neighbor. So we have our router ID, cluster ID. If you know anything about route reflectors and cluster IDs, you should know this is basically, hey, for route reflection, since I have two route reflectors, if you see the same ID in a route or in any route, you're going to reject it, right? Now, for route reflector purposes, this allows IGP to work without the full mesh requirement, right? If I didn't have route reflectors, you would need to have a full mesh, everybody in the service provider network. Now, there are some limitations, or there is a downside using route reflectors because you're taking the path from the view of the route reflector and not the PE itself. If you wanted to do it from the PE point of view, you use optimal route reflection. I have a video about that as well if you want to see what optimal route reflection is. So the main change here is this address family group here, which is address family IPv4 and VPN. This allows you to run multicast through the provider network in the separate VRF that's going through the service provider network. So through the MPLS L3VPN network. If you don't have this on here, you can't do MVPN, right? The old way, which is profile 0, this would be address family IPv4 MDT. So the AFI would be IPv4, the sub AFI would be MDT. In this situation, the AFI is IPv4, the sub AFI is MVPN. Now, if it was IPv6, obviously the AFI would be IPv6. And then we have our VPN v4 stuff. Typical here. Okay. So you know what? Let me show you the summary here while we're at it. So we go show BGP, VPN v4, unicast, all summary. That shows you the routes there. Now I'm not getting anything from 17 because I'm using the same cluster, so I'm not exchanging routes per se. So my route reflectors are not just sending the same routes that it already knows to another route reflector that already knows the routes. So 17 is not going to show me anything, but everything else is going to be there. So we should show BGP, IPv4, and VPN. Oh, I think summaries in this one as well. Yep, summary. Same thing. I'm getting the MVPN routes everywhere except 17 because that's the other route reflector. Now, in terms of routes, you have a route type 1, which is your auto discovery route. You got a route type 2. You got a 3 and 4. Now, 3 is going to be for your SPMSI, which is selective, which is the data MDT. 4 is your leaf AD for that SPMI. 5 is going to be a source, right? So if someone is advertising a source for a certain, there's a source for some traffic, right? 6 is the shared tree. 7 is the SPT tree, or the shortest path tree. Now, when I show you this in the BGP BGP IPv4 MVPN table, you're going to see those routes. Now, before anybody does any of this, you really need to understand how multicast works. If you don't know how multicast works, you kind of can't do MVPN, right? So this is where learning the basics of multicast routing will help you in the long run, because in order to do something as advanced like this, you need to know how multicast runs. So if I were to do, let's just do all here. So here's the routes. Like I said, there's the ones, which is basically everybody that's joining the default tree, right? So that's the auto discovery stuff. And then we have this 6 here, which is a shared tree. So this basically says, hey, somebody's trying to join the group 224.111.32. If you look at some on the, I'll pick up router 9. If I look at the loop back here, you're going to see the IP IGMP join group 224.111. So that's how we test to make sure multicast is working. So here it is. That says I want traffic to this group. So I'm joining this group. This would do the report, and then that report, which is, IGMP is a layer 2 protocol, that will turn into a PIM join. Okay. And that's in multicast. You got to know what report, PIM join, PIM prune, register message, which is from the source side, stuff like that. So this is how it would look like here. Now let's go to a PE so I can show you the configurations from the, now I'm gonna show you iOS XE, and then I'll show you iOS XR. Now the XE configurations here is under the VRF. So if we look at the VRF, I have a VRF cus A for customer A. Now we look here, let's go through this. So here's my route distinguisher, which again is just a route distinguisher to 64-bit. Remember, IPv4 routes or VPN v4 routes are technically 92, and then IPv6 is 192. Okay, so 64 plus 32, right? So 96. I had it wrong on the math there. For VPN v4, sorry. So here we go with the auto discovery PIM. This is where the VPN profile 13. So let me side quest real quick. You're never going to know all these profiles off the top of your head, just flat out. Like, unless you do this a lot and you do MVPN for a living, basically you just live in it. There are some things that you're going to forget. While I was doing this and I was like, do I want to do profile 1, 3, 11, or 13, which is the main ones they teach you. I said, I'll do 13. And I got 13 on iOS XE like the back of my hand. iOS XR, I missed like 1 or 2 things, and I was like, oh yeah, you got to do this. So again, you're not going to remember off the top of your head unless you're really living in this. So this auto discovery message is going to be PIM. This is where the GRE stuff comes in. The default MDT, which is the MDT that everybody, now MDT means multicast distribution tree. The default MDT that everybody joins is going to be 232.110. The reason why I'm doing that, because I'm doing SSM default in the core. So therefore, there is no RP. There are no RPs in the core, right? So this is source specific multicast. Most people, from a recommendation standpoint or from a best practices standpoint, they do SSM default, right? Because you don't really need the RP that much, right? Now, some people do use the RP internally, but again, service provider network, you're probably better off doing SSM default. The data MDT, now the data MDT means, hey, if I go past a certain threshold on the default MDT, I'm going to switch over to a data MDT, which is a different multicast group for that traffic. And this is where the SPMSI, Selective Provider Multicast Service Instance, comes in, right? The default MDT is the provider multicast service instance or interface, whatever they want to call it, right? Everybody joins that, and then when you reach a certain threshold to optimize it, right? So this is a data optimization strategy, which is, hey, if you're sending too much traffic on the default MDT, that goes everywhere. The default MDT goes everywhere, right? But if only a certain subsection, and this is where selective selective or SPMSI comes in. If only a selected group wants this traffic, then I'm going to get off of the default MDT, switch over to the data MDT, and send the traffic on the data MDT. So it'll be a different multicast group, right? And since I have, this is a /24, so I got all the way from, 1 to 254. The MDT overlay use BGP. This is where the multicast or the CPIM signaling is going to be done in BGP, right? And this is where the 5, 6, 7 route type comes into play, because it's going to say, hey, your shared tree is type 6 again, your SPT tree or your shortest path 3 is type 7, and the source is type 5. So the minute I start pinging to this group 224.111, you're going to see a type 5, a type 6, and a type 7. And that's when multicast is going to work. So this is all you really need to do on the VRF side, right? Then you need to activate it under that multicast, under the VRF, specific VRF. Now, this distributed command is really based on the router, right? iOS 6, so you got to use distributed. If you just do iOS, you just do it under the VRF. There's no distributed command there, or distributed command there, right? So once you do all this and everything joins the MDT, let's first look at the MDT from the M route perspective, so our multicast route. Again, this is where you need to learn multicast before you do any of this, right? So if we just do show IP M route, so as you can see, we're showing the IP M route, right? These are all the routers that have joined that MDT, right? That have that IPv4 and VPN and have the VRF configured basically the same way everywhere. So we have 22, we have 20, we have 1, which is the router I believe I'm on, then 21, 19, and 2, okay? And we're all joining that default MDT of 232.111, as you can see, right? Now, the inbound interface for 1 here is, you see we have loopback, and then it's going out to 2, right? So this is just default MDT stuff, right? Once we start sending traffic, you'll see when I do it under the VRF, like if I was to do this under the VRF, let's see VRF, cuss A. So I do it under the VRF. You see this star comma G for 224.111. That means, hey, this is the shared tree. Somebody is looking for traffic to this. We don't know the source because it's a star right now. We don't know the source, but we know with the group they're trying to join, it's going to come in through the tunnel interface and go out of 5. So once I start pinging this, it'll go through the tunnel, because these are GRE based tunnels, and then it will go out to 5, because 14 has the same thing on the loop that I just showed you, which is, hey, IPIGMP join group 224.111. And that's why we got the star comma G here. Now, what happens when you do those VRF and MDD stuff, right? Oh, the MDD, and you have to put PIM sparse mode everywhere. Every interface has PIM sparse mode on it, including the loopbacks. I forgot to mention that because I want to mention that there. So if I went and just showed you a regular loopback, I don't even have to do that. I just use show IP PIM interface. So these are the PIM interfaces in the global routing table. This is GRT, all right? So PIM is on, all that good stuff there. Now, if you want to see the PIM interfaces under the VRF, you just show PIM VRF cus A interface. There we go. So now, if we look at this, what you will see is this is the GRE tunnel that's automatically created once you do those VRF commands, right? You don't actually see this. You didn't configure this. This is automatically configured once you do the MDT stuff under the VRF, right? And then you enable multicast and all that. This will be automatically generated. And this is what's taking that PIM traffic or that multicast traffic over the service provider network and in your VRF. Without this, if this is not created, multicast wouldn't work. Okay. So now that we got the tunnels, we got all that created, we're good to go, right? Now, just to make sure you know that there are no RP, so there's nothing there, right? Now, if we go do the same command here, VRF plus ARP mapping. So what we should see is the RP of R16. Now that is on PE1. You know, when I'm doing BSR, so bootstrap router, which most people are going to do in the real world, they're not going to use auto RP because if you do auto RP, now you have to enable sparse dense mode on the link and not sparse mode. So this is saying 16 is the bootstrap router, which is the RP, basically. All right. Now, if I go to 14, that's the service provider network. If I go to 14, now I'm doing BGP everywhere here. So if you go to 14 and I go show IP, now here's the thing. Outside with the client, there's no VRF enabled. This is all global routing. This is all global multicast. So if we do show run section IP multi, make sure that's not two M's. See, it's only multicast in the global routing table. And we do show PIM interface. I should say open. There we go. PIM interface. There we go. Our PIM interfaces on the global routing table. And then if I do show IP PIM RP mappings, that's our RP mapping for our RP. Whenever this decides it wants to, make some sense here. Just taking a little while for it to kick in. So now we know and this is everywhere. So now we know we have an RP, we have all that good stuff there. All right. From an RP standpoint, since R16 is the RP, what we will do is we'll just do show IPM route. All right. So IPM route knows, hey, somebody is trying to join, get out of here. Somebody's trying to join 224.111, and I'm sending that out of G00. So now let's do the actual test. So here's my server. Move it over here. And what I'm going to do is I'm going to ping 224.111. I'm going to repeat it 10 times. And now we got some responses. So we should see one from 14, 12, 9, and 11, because those are technically my receivers for this traffic. So that's 14. Come on, that's 9. We're looking for 2 more, 12 and 11. That's 12. And that's 11. Well, while that's going, Let's refresh the M route, and now we should see the star comma G, or the S comma G, sorry. Here's your S comma G. So this is source is 172.16.101, which is on the MCAS server, is going to here, okay? Which is going to 224. So now, if we go to router 1, as that's still going, let's see what we got here. That is still going. And I'm going to pull up the MCAS server as well. Move that out the way. I know that's still going in the background. So as that's still going there, what we're going to do, we're going to do show IP, show BGP actually, show BGP IPv4 and in all. So what I specifically want to show you here is the routes that I was talking about. So here's your source routing here, right? So that's a 5. That's the source. Let's say, hey, somebody's trying to get into here. Now, all that stuff is now in BGP. This is why BGP is so great, because you can do so much stuff in BGP. But here you go. Here's that 172.16.1 going to 224.111. So that is a advertisement or a type 5 route that says, hey, there's a source trying to get to this multicast address. Here is the type 6 that says, hey, we got clients that want to get to 224.111, and this type 7 is the actual SPT tree that says, hey, 172.16.11/32, this is source that's going to 224.111. So now that's the tree that everybody hops off. The SPT tree is what everybody hops off after they get to the shared tree. They get, the first packet that got the source and the multicat of the source. It has the source IP, or the I would say the IP address of the source of the multicast traffic, right? And then everybody jumps off of the shared tree, gets to the source, the SPT tree. That's basically what this is. So now that is multicast in a nutshell, right? And I'm going to show you what it looks like on iOS XR in a minute. Let me see, is there anything else I want to show you from this side? Let me show IP mroute. We got any mroute stuff in here. This is going to be that one. We go show IP mroute VRF cus A. So now you can see it is also, this is what I wanted to show you again. So this traffic, or this source that's going to this group, the incoming is tunnel interface, right? And the outgoing is 5. That's why these are responding as I'm pinging that multicast group, right? So what does that look like on iOS XE? So I'm going to grab iOS XE here, pull this over. iOS XE, iOS XR is a totally different beast. All right. So let's slide this down here. Now, first things first, commands are a lot differently. So the one thing about iOS XR is it's kind of like Juniper, really, when it comes to like syntax. You can kind of do one-line syntax, sort of like what you can do on Juniper. So I'm glad that you can do one-line syntax. It's a lot easier as long as you know the commands. You can just type everything out in one line. So the first things first is we need to look at multicast. So multicast is a little different here. So as you can see, from a multicast perspective, we have multicast routing. Globally, you have to have this MDT source loopback because you're sourcing it from the loopback. You have to have this in global, and you have to have it under the VRF, right? So this is under the VRF. Here's the same PIM auto discovery. This is the MDT and the default MDT and the data MDT. So you have to put that in there. There's a little different now to do the core. You're going to have to do a route policy that sets the core tree to PIM default. And that's going to be under router PIM. So if we go router PIM, as you can see, PIM is enabled. See, the thing about multicast and iOS XE, iOS, and iOS XR is once you enable multicast or PIM sparse mode and multicast in global config mode, you're cooking on iOS and iOS XE. on iOS XR, you have to turn on multicast and you have to turn on PIM, right? So you have to, if you turn on multicast on the interface and not PIM on the interface, it doesn't work. So it's another subsection here. So here's the global configurations for PIM, and then here's the VRF configurations here for PIM. Now here's the MDTC multicast routing. This is the CPIM for using BGP for signaling. And then this route policy here is to set it as PIM default. So if I do show run route policy SSM, you see here, core tree default, right? So you got to put that in there. Now, once you do that, the multicast configuration or the BGP configurations are a lot different here. So if you go show run router BGP, we're just going to stay specifically here. Now on iOS XR, you need to enable the address family before you can actually use it, right? Sort of like Nexus, how you have to enable a feature before you can use it. You have to enable the address family before you can use it. So we have MVPN, we have the address family at the global level. We have VPN v4 and then MVPN. I don't know why I just did that. Then we attach, now I'm using neighbor groups for this. So this is sort of like, neighbor groups are sort of like templates, but they just didn't use the template command. So I have neighbor groups for this. Then you just use the neighbor group. And then under the VRF, now the difference in iOS XE and iOS again is you put the route distinguisher under the VRF definition in iOS XE and iOS. In iOS XR, you put the route distinguisher under the actual VRF in BGP. Gets a little confusing when you do it. Kind of makes sense though, because the route distinguisher is technically a BGP attribute. So putting it under the VRF, it's not a VRF attribute. It's a BGP attribute. So it kind of makes sense to put it under the BGP. The subcommands are subconfigurations here. Then you need to enable it under the VRF. Then you do your normal BGP configurations, and this route policy pass in and out is just basically a pass command. This RPL is a very intriguing. It's a route map. There's no route maps in iOS XR. Technically, there's no route maps, but a route policy is what replaced route maps. And route policies or RPLs are a lot like programming language. So if you're used to like Python, if statements, if else statements, else if statements, you can do that in route policies. So if you wanted to do something like if RPL statement would be like if destination is parentheses or if destination in parentheses, whatever the subnet is in the parentheses, then pass, else if this, else if this, and then at the end you just do an if. So you're going to have to learn a little bit of programming, think like a programmer when you're using RPL. But the general rule is from a routing perspective, by default, eBGP routes are denied by default if you don't have a route policy that says, hey, does it have the pass attribute in it to allow it to pass, to send routes and receive routes. That's why you see one for in and one for out. So if I showed you the route policy pass, it would just have the pass statement in there. That's it. So that's saying, hey, you're allowed to send routes and receive routes. So now to show the MRIB table, to show the multicast table, you would just show MRIB routes, right? And this is where you're going to see your MDT stuff, your default MDT stuff, right? And then if I did show MRIB VRF CUS A routes, this is where you see specific to the multicast groups, right? So it's still multicast and all that stuff. That's still there, right? Since we're still sending traffic. So you can see show IPM route is on iOS XE and iOS, and then you have to use show MRIB routes or MRIB, whatever the VRF routes in iOS XE. Just like I told you before about the forwarding, You do show MPLS forwarding in iOS XE compared to iOS XR, which is just, you know, or so you do show MPLS forwarding in iOS XR compared to iOS XE and iOS, which is show MPLS forwarding table. This aggregate is basically the routes that are in the VRF because you see it's a V, so it's a VPN route. That's really it. And that is multicast over an MPLS network in a nutshell. Right now, this is doing it in MPLS L3 VPNs. Now, I've seen people try to marry the two, like have global MPLS for global routing and VRF. Uh, and VPN, got to be careful mixing that up because you need to know exactly what you're looking at. Is this a GRT or global routing table multicast issue, or is this a MVPN MPLS L3 VPN issue? Again, this is, multicast in the service provider network in a nutshell. Now, this is profile 13. This is not MLDP based because I didn't want to do ingress replication, which is basically what MLDP is. But if I were to do it, I would pick probably two routers in the core to be my MLDP routes, and then it would basically label it with a specific MLDP label since it's an extension, and then it'll get replicated out. But I didn't want to do that. Hopefully this video was informative. Don't forget to share, comment, like, and subscribe. If you like stuff like this, let me know because I wanted to follow up on this video because I did do a video about multicast routing, a theory video, and I didn't show you what it looked like in the lab. So if you like more videos about this type of super advanced type of stuff, let me know in the comments and I'll just start creating like really elaborate labs and showing you like cool routing tricks and stuff like that. This is Don from Padlock Technologies. Thank you and have a nice day.